Let me tell you the method of teaching that I'm going to follow. If you have any objections, let me know immediately. So my method of teaching is very simple. I'll first focus on algorithm. I first focus on algorithm, understanding what the algorithm is. What is the idea behind algorithm? How the algorithm actually go, and we will be focusing on paper how this algorithm should run. On paper, how this algorithm should run. I'm expecting अगर आप लोग डेटा स्ट्रक्चर जैसा मॉड्यूल पढ़ रहे हो, you should have a notebook beside you with the pencil, eraser, pen, whatever that you need, you should be having with you. अगर आपको ज़्यादा better output चाहिए तो, if you are just in listeners mode, there are likely chances that you will find it most troublesome module, because after that you will be in a question, सर इतने algorithm आपने पढ़ा है, हम इसको सर याद कैसे रखेंगे? Algorithms are not to be by-hearted. Algorithms are to be understood. The algorithms need to be confirmed. क्या ये जो algorithm सर ने बताया is the same algorithm? तो सर how do we do confirmation? There are 2-3 rounds of confirmation. जो बता रहा हूँ उसको ठीक से सुनो, so that we are like क्या कहते हैं उसको, in sync. हाँ, the very first thing I'm saying that ideally I should be showing algorithm with you. यहाँ पर मैं आपको algorithm बता रहा हूँ. One time, two time, three times, you say as many times, we can definitely repeat on algorithm. There is absolutely no problem. But just by listening the algorithm, you will never be comfortable. At the same time, you should do it by yourself as well. So like taking a similar example, you try it on paper. As you try it on paper, you find that yes, it is going good. That is second step. Third step, ideally, you should be logged on your system. And if you're logged on on your system, on your computer, ideally you should copy paste the code and run it with me. कोड शेयरिंग मैंने ऑलरेडी चालू कर दिया है, सो आपने ऑलरेडी उसको कॉपी करना चाहिए और आपने उसको एग्जीक्यूट करना चाहिए. दिस इज लाइक अ थर्ड थिंग. बट वेट, फोर्थ थिंग. तो सर इतना करके हो जाएगा कॉपी पेस्ट से? टू बी फ्रैंक, सम सिंपल एल्गोरिथम्स लाइक लीनियर सर्च, सिलेक्शन सॉर्ट, बबल सॉर्ट आपने इससे पहले भी कभी ना कभी किए होंगे, तो यहाँ पर ये काइंड ऑफ रिवीजन हो जाएगा. दैट इज फाइन. कॉपी पेस्ट कर रहे हो, वर्क हो रहा है, दैट इज वेरी गुड. But after that, when you go to the lab, what you should be doing? When you go to the lab, I again recommend that you should again do the paperwork. Whatever algorithm that you have learned, why don't you try it on paper once again? You try it on paper once again. You try to, already code will be shared, no doubt on that. You can try to build the code once again by yourself and then type the code on your own. I repeat, for the simple algorithm, you need not to waste your time. Rather, I recommend for the stupid algorithm, you should not spend your time. The algorithms which need more time, algorithm like you learn quick sort, merge sort, it will take its own time. So you spending, at least 1.5 hour on quick sort, 1.5 hour on merge sort, it is necessary. You spending, I'm not saying that I spending. मैं तो यहाँ पर क्लासरूम में पढ़ाने ही वाला हूँ. I'm saying that your own time with paperwork and actual typing will give you more confidence than just listening or just copy pasting. So while the lecture is going on, you can copy paste with me, but when you go to the lab, these kind of stuff you should type by yourself. Apart from that, I have planned some of the assignments for you. Now the assignments are usually kind of application oriented. So whatever that algorithm that you learn, like a basic algorithm, but how do you put it in practical or like given scenario? So you need to think upon that. Uh, I just don't want to make this assignment absolutely compulsory to everyone, because that will change from the student level to student level. And I do not really even want to waste my time into the assignment discussion, because if I spend time on assignment discussion, I will not be able to catch up with your the syllabus that I'm supposed to give it. But assignment still I have planned, because every batch there are some ambitious students. So I want, if you are ambitious enough, you are like done with like a basics, you go ahead and you try to solve those assignments as well. Those assignments should help you more, no doubt. And at the same time, if it is possible, rather make it possible. Now you people are well acquainted with each other. Start working bit groups and subgroups where you can discuss the things once again. You can discuss the things once again. You can discuss the some of the like assignments नॉट द कोड आई एम टॉकिंग अबाउट। असाइनमेंट, ये असाइनमेंट है, तो यहाँ पर असाइनमेंट में एग्जैक्टली क्या करना है, what logic is needed. So you can discuss among yourself and then try to write your own code. Someone is saying that for assignments we always discuss with the lab mentors. Yes, lab mentors will be available, but trust me, you do not discuss with the lab mentors, you get the solutions from the lab mentors. Getting solution from a lab mentor is a different thing and discussing is a different thing. I hope you are getting the difference. Because I was saying that जब मैंने शुरू किया था, I just started, कुछ लोग late join हुए थे, I guess I should be saying that the very first intent of this module is to build the thinking abilities. And trust me, thinking ability तब नहीं बढ़ता है when you know the right solution. Thinking ability तब बढ़ता है when you spend your time even on the wrong solutions. When you discuss the ideas, that improves on a thinking ability. Just getting a ready-made solution, sir ये ऐसे है, sir इसमें क्या करना है, तो your faculty says that अब इसमें ये करना है, so you go and implement that, where your thinking ability is improved. When you discuss among each other, you do the bit of, you call it the brainstorming process. That brainstorming process is somewhere required अगर आपको आपके thinking abilities को improve करना है. तो I suggest definitely lab faculties are available and you should be definitely talking to them as well, but this will give you the better idea of the module or why data structure is to be learned, right? So I hope you got the point. Anyway, चलो अब मैं आगे बढ़ रहा हूँ. What I'm trying to tell you is that मैं कहाँ पर था, हाँ लीनियर सर्च. तो मैंने आपको आइडिया बता दिया. हम लोग एल्गोरिथम कैसे पढ़ने वाले हैं, हम लोग पहले एल्गोरिथम ऑन पेपर पढ़ेंगे. वी विल ट्राई टू इंश्योर दैट कि एल्गोरिथम क्लियर हो गया. एंड वंस यू से दैट एल्गोरिथम इज क्लियर, देन आई विल गो ऑन टू द कोड फ्रंट. I will go on a code front and then I will type a code in front of you. We will compile it, we will run it. At the end, you can copy paste the code, you can execute by yourself and see that, oh yes, it is working. And if the code is big enough, please go ahead and what is that? Please go ahead and क्या कहते हैं, type it once again. Linear search is very stupid one. You need not to. Someone is saying that code sharing is not working or portal is working very slow. Is it so? No idea. वैसे टू बी फ्रैंक मैंने अभी तक कुछ शेयर किया ही नहीं है. अच्छा, नॉट लॉगिंग इन. अच्छा, अनेबल टू लॉग इन. ओके 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 ओके. हाँ, सो इट अंडरस्टूड. आई लुक लाइक, नहीं, देयर माइट बी सम इश्यू एट द इंटरनेट एंड एज वेल, बट देयर कैन बी, देखो कुछ लोगों का इट इज वर्किंग, कुछ लोगों का इट इज नॉट वर्किंग. एनीवे, कंट्रोल F5, यस, प्रणाली गिव्स सम सॉल्यूशन. Okay. I see, the varieties. So few people not working, few people are working, and few people are like different. Anyway, we can do one thing. वैसे immediately नहीं लगने वाला है. You first find out, and if you at all need, don't worry. Listen. We will do on a multiple ends as well. Absolute no issues. I will also copy it into this. Whatever the file is created, I will take care. Just give me the reminder. And I will also copy it into the Zoom chat. So I will copy the whole file so that you can just take it from there. So we will work out on the mechanism. एक चीज अच्छी है डेटा स्ट्रक्चर के मॉड्यूल में कि हमें कोई बहुत बड़े बड़े, क्या कहते हैं उसको, बड़े बड़े कोड नहीं करने. So we will find out some alternative, and parallelly definitely we will also, I'll also check with the backend team whether any checks are to be needed onto the software front as well. Anyway, that we can do it on a parallel. चलो अभी हम लोग आगे जाते हैं. Let us not waste too much of time. हम लोग कहाँ पर थे? So let us get started with the algorithm first. Linear search. अब इससे simple algorithm तो वैसे भी हो नहीं सकता. What is linear search algorithm? The linear search is that you have got list of elements. When I say list of element, it could be array, it could be linked list or whatever you said. So linear search simply means that you start accessing the elements one by one and you compare whether it is matching the given number or not. So find a number in a list of given numbers, and the numbers may not be in a sorted order. The numbers might be in an unsorted one. So anything, I really don't know. So what is to be done? I'm just going ahead and like one by one. The very first, what I can do, I can take a simple loop variable. I can take a simple loop variable and I can begin comparing. Let's say, for example, I want to search element 22. This is, let's say, element that I want to search. This is the element that I want to search. How do I start? I start with I is equal to 0. Take a look at this. I is equal to 0. Is it matching 77? Not really. I plus plus. Is it matching 77? Not really. I plus plus. Is it matching 77? Not really. I plus plus. Is it matching 77? Not really. I plus plus. Is it matching 77? Not really. Is it matching 77? Yes, I found that this is matching 77. And if this is matching 77, whatever, either you return the address of that element, you return the pointer to that element, you return the index to that element, that is up to you, depending on a programming language that you have chosen. What linear search says, the linear search simply says that you start from the first element and you go step by step. You start from the first element and then you go step by step, step by step, step by step, till the element, till the element that you found. This is what you call a linear search. So इसमें कोई बहुत बड़ा explanation or like heavy programming नहीं है. हाँ, but there are definitely some of the special cases that I want to consider. Like one special case, the element that you are searching, listen carefully, the element that you are searching, let's say you are trying to find out 88. You are trying to find out 88. Don't you think that the element that you are searching is available right there? The first iteration itself, I found the element. What is this? What is this? This is where you need the minimum number of iterations. And if this is where you need the minimum number of iterations, I can say that it is best case. So best case where you need the minimum number of iterations. Minimum number of iterations, you say is the best case. Again, please think more what is that, rationally. You have got array of 10 elements. Element that you are trying to search is the first element. How many iterations that you need? I need only one iteration. Let's say I have got an array of 1000 elements. I got an array of 1000 element. The element that I'm trying to searching is still first element. How many iterations I need? Oh, still again it need one. Again, I got an array of 1 million elements, but the element that I'm searching is still the first element. Still the first element. What you see over there? What you see over there? The time required is not dependent how big your array is. The time required in this particular case, a time required in this particular case, you can say is a constant time. Why it is constant time? So you find that only one iteration, only one iteration, irrespective of how huge your array is. And when is the time required is constant, I can say that it is O of 1, or you can even say it is kind of omega of 1. अब O of 1 को या फिर omega of 1 को, but then omega is something that I was trying to tell you कि वो minimum इसके लिए usually consider किया जाता है. Usually, as I say that the practically, जब भी हम लोग काम करते हैं, जब लोग कंपनी में जाओगे, अगर if at all you work at the level of like performance tuning of the algorithm, at that time usually we do not bother about like what is omega and what is theta and etc etc. We only talk about like a big O notation only. And with the big O notation, you say it's the O of 1. O of 1 seems to be a best case, but then what could be the worst case? The worst case is probably you are trying to find the element, you are trying to find the element which is either a last element or the element not found. Let's say, for example, in this particular case, oh, my mistake. Now you continue further. And let's say that you are trying to find out 11. As you are trying to find out 11, and I'm saying that either it is the last element or the element doesn't exist at all. So in this particular case, what I need to do, I need to start I is equal to 0. Is it 11? No. I plus plus? No. I plus plus? Still not 11. I plus plus? 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 And I found that yes, it is 11. So I found the element is found over there. So here you need to go through all the iterations where I can talk about like a maximum iterations. So in which case you need the maximum iterations? In which case we need the maximum iterations. There are two possibilities. ये two possibilities, या तो element not found है या फिर last element आप लोग search कर रहे हो. In either case it is going to take n iterations. So in this particular case अगर आपका 10 का array है, 10 का array तो ज्यादा से ज्यादा 10 iterations. अगर 100 का array है तो ज्यादा से ज्यादा 100 iterations. और अगर 1000 का array है ज्यादा से ज्यादा 1000 iterations. So again max to max I'm saying that the time required is proportional to n. And if I say time required is proportional to n, you usually say that it is O of n, order of n. जैसे जैसे n grow होता जाएगा, the worst case time may grow. What all you are saying? And then you talk about, but sir, ऐसा कभी होता नहीं है that we are too lucky that you get the element at first, or we are too unlucky that you always get the element at the end. You know, the real world, there will be a kind of a combination, isn't it? In real world there will be a combination. There will be few times I may get it early, few times I may get it at the end, few times I may get it in between. So the things might change. So if the same experiment I run it again and again, same experiment I run it again and again with the different random numbers, with the different random numbers, there are likely chances are that the time required or the number of iterations required are like varying. Yes, number of iterations might be varying, but if you take, you're running the same algorithm again and again with the random numbers, and you take an average of it, I would say that then you can talk about on an average how many iterations that you need. I can say that on an average, if there are n elements, I can say that n by 2 iterations that I need. By the way, ये proportionality का साइन है. ये proportionality का साइन का मतलब क्या है? यहाँ पर प्रोपोर्शनलिटी में वैसे भी कांस्टेंट कंसीडर नहीं होते. आई होप आपको पता होगा. इवन ऐसे टाइम रिक्वायर्ड इज प्रोपोर्शनल टू n by 2 बिकॉज मैंने एवरेज निकाला ऑन एन एवरेज ऐसे n by 2, बट विद द n by 2 1 by 2 is a constant, and if 1 by 2 is constant, this is ultimately meaning time required is proportional to n, isn't it? And if the time required is still proportional to n, a time required is still proportional to n, I can say that it is theta of n. It is theta of n, or you can say that O of n once again. O of n once again. I'm saying that like a worst case, like a best case, like an average case. So these are three different cases that we are trying to talk about. Hey, by the way, it was about time complexity. What about for the space complexity? Hey, what about space complexity? Hello? What about space complexity? Any idea? The space complexity, again, you talk about two, three things. A first thing, you talk about like an input space. Yeah, how much is the input space? How much is the input space? बेसिकली पहले आपको एरे तो स्टोर करना चाहिए ना. बेसिकली आपको एरे स्टोर करना चाहिए. अगर एरे 10 एलिमेंट का होगा तो जो साइज लगेगा वो, अगर एरे 100 एलिमेंट का होगा तो जो साइज लगेगा वो, और अगर एरे अगर 1000 एलिमेंट का होगा तो जो साइज लगेगा वो, obviously the size is changing with respect to number of elements. I can say that input space is depend on number of elements, and I can say that it is order of n. But what about auxiliary space? Auxiliary space. The auxiliary space is like how many extra variables that you might need to solve this. अगेन अगर आप इसका कोड लिखते हो, कोड इसका बहुत ही स्टूपिड सा कोड है. फॉर i is equal to 0, i is less than n, i plus plus, and then simply you are checking that if it is matching with the key written. So you need only one I as a extra variable, or even though for that sake, even though you count the key to be searched, but it is fixed. Again please understand that it is fixed. अगर आप लोग 100 के एलिमेंट में 100 के एरे में सर्च कर रहे हो या फिर 10,000 के एरे में सर्च कर रहे हो, the number of variables that you need, they are not changing. I repeat, वेरिएबल के अंदर की वैल्यू बदल सकती है, बट वेरिएबल को स्टोर करने के लिए जो साइज चाहिए, that size is not changing with respect to the number of elements, and I can say that the space required will be the constant. And if it is constant, you can simply say that it is O of 1. But sir, what exactly it needs? There you can write a small code. वैसे जिन लोगों का टाइपिंग अच्छा है, I do even recommend that if it is possible, आप लोग मेरे साथ टाइप करो. मेरे साथ नहीं, इनफैक्ट मेरे से पहले टाइप करो, बिकॉज इट यूजुअली हैपेंस दैट आई कीप एक ही एल्गोरिदम में 2-3 बार एक्सप्लेन करता हूँ और एल्गोरिदम्स कभी-कभी इतने स्टूपिड होते हैं कि वो देख के अच्छा ये ऐसे ही तो करना है। सो यू कैन इवन स्टार्ट बिल्डिंग अ लॉजिक बाय योरसेल्फ। यू नीड नॉट टू इवन वेट कि सर कब करेंगे, फिर हम लोग सर का कॉपी पेस्ट करेंगे। ये करने की कोई ज़रूरत नहीं है। ये करने की कोई ज़रूरत नहीं। सो आई एम जस्ट गोइंग अहेड और मैं आपको क्या बता रहा था? द टाइम हाउ डू यू राइट अ कोड? इट इज़ वेरी ईज़ी। फॉर i is equal to 0, I is less than n, I plus plus, all I need to do is that if array of I is equal to the element to be searched, अब जावा में पॉइंटर्स नहीं होते तो आई कैन रिटर्न ओनली द इंडेक्स, आई कैन रिटर्न ओनली द इंडेक्स, बट इफ इट इज नॉट देयर, if it is not matching, then I can say return -1. If why -1? Why not 0? A 0 itself is a valid index. So I'm just saying that if the element is found, if the element is found, return index. Return index if found. Return -1 if not found. Correct? So that kind of simple logic we are trying to build. I guess we can go ahead, we can type quickly, we can run, and then we can go ahead. So you just talk about create a Java project. I'm very sure आप लोग expert हो Java के program project बनाने में, and then I can go ahead, let's say searching. Next, आप लोग भी आई होप आप लोगों ने Eclipse ओपन कर लिया है और Eclipse ओपन करने के बाद में आप उसके ऊपर now it is dealing with Spring. इसको अचानक से Spring की कुछ तो याद आई लगता है. Some of the Spring tools it is updating behind the scene. Let me check whether the internet is stable. Look like. I'll wait a little, otherwise I will. वैसे आप लोग चिंता मत करो. द थिंग इज दैट आई हैव जस्ट बिट ऑफ मेरा इक्लिप्स जो है वो लेटेस्ट इक्लिप्स है 2020 9th और दैट थर्ड क्वार्टर. सो दैट इज बिन देयर. सो इट माइट बी कुछ अलग फीचर आपको दिखाएगा बट इट शुड नॉट बी अ बिग डील. सो आई एम राइटिंग लेट्स से सर्चिंग मी. All right, this looks good, and we have got like a main. All right, I found this. Let us get started. I'll start writing a method. Let's say linear search. Okay, that is good. You take the array, and not only you take the array, you also look for which is the element that you want to search. How do you write this? As I said that it should be very simple. For integer I is equal to 0, I is less than array dot length, I plus plus. If error of I is equal to key, I found the element, you simply say return I. Otherwise, return -1. Correct? So here मैं यहाँ पर क्यों लिख रहा हूँ, मैंने ऑलरेडी वहां पर लिखा हुआ है. That's it. If the element is matching, return the index. Otherwise, return -1. How do you call this? Go ahead, declare an array. By the way, we are here to learn data structure, not Java. जो कुछ भी जावा आपने ऑलरेडी पढ़ा हुआ है, you can always recall it back and you can always work on that. I have designed some of the assignments which will help you to go back and recall your Java stuff as well. However, I'm not over here wasting too much of time in like how to what is that, take the input from the user, फिर scanner declare करो, फिर उसको run करो, फिर उसको input user से ले लो. I'm not going to waste my time. You can always go ahead and improve on this flow code. Right now, I'm just taking some array and purposefully I'm taking an array which I have shown it into my diagram. 66, let's say 99, let's say 44, we have got 77, we have got 22, 55, and we have got 11. Is my array is there? And then you continue further. You want to search an element. Okay, utna part mein user se le raha hu. How do you search an element? I guess we use something called a scanner. Scanner is equal to new scanner. Okay, this is there. System dot in. All right. You continue further. You ask user. Okay, enter key or element to search. To search, to find, whatever you want to say. It's up to you. And number that you want to search is nothing but how do we take an input is like this. And then you make a call to the function. Let's say linear search. You pass the array, you pass the key. Okay, that is good. What it is going to return me? Yes, it is going to return me the index. Oh, I got the index. And if I got the index, I want to check if index is not equal to -1. I probably want to give a result. What is that? What is that? Key found at index something, you call it as a index. All right. Else you want to give a message that key not found in array, whatever you want to write it, go ahead, write it. That's it. Yes, this is done and nothing more that you need to do beyond this. So इतना ही करना है, absolutely इतना ही करना है और कुछ भी करने की जरूरत नहीं है. Right? Let's just go ahead and to run the application, run as Java application. Oh, good. It is executed and I'm trying to search 33. Oh, it is found. That is great. You continue further. I want to find out element, let's say 55. Oh, probably it was somewhere at the end, at the index 7. Oh, that is also working. You run it once again. Let's say you try to find out element 20. Oh, it doesn't exist at all. Quite good. I hope things are pretty clear, pretty straightforward what linear search is, how linear search execute, and so on and so forth. If your code sharing is working, that is great. You can copy it from there. If code sharing is not working, Zoom chat I have already copied. You can take it from there. You can execute it. And as I said that such a simple program, I do recommend that ये program आप लोग जब मैं algorithm explain कर रहा हूँ तभी भी आप लोग type कर सकते हो. There is nothing great in these basic algorithms at least. When it comes down to the advanced algorithm, definitely now you need to pay attention. If someone could complete this, execute this, can give a little confirmation, and then we can go from there. Yes, good. So things are working well. As I say that linear search इस algorithm में कोई भी बहुत दिमाग लगाने वाला या कोई तो बहुत complicated या कोई special algorithm है, ऐसी कोई बात नहीं है. So linear search is like pretty simple. You have understood it, and then we can continue further on to the next algorithm. By the way, just one or two things that I want to ask. Okay. So what I was asking you is that this is hopefully comfortable, and then we can continue further with the like next algorithm called a binary search. So मैं आपको ये पूछ रहा था, what is usually your break time? Let's say break time, the duration I'm asking you. The usual break duration, 15 minutes is good. Okay, no problem, no issues. We will just go ahead. Yeah. वैसे we will go with the majority. So few people can also say that, sir, हमारे लिए we don't need a break. We need only 5 minutes break. So it is up to you. Usually nearby 11 o'clock, we will have our first break around 15 minutes, and then probably we can have one more break nearby 12 o'clock for the 10 minutes. Right? So don't worry. Chalo, we can go ahead and we can talk about the next algorithm. The next algorithm we are talking about like a binary search. So let us just take a look at the idea what a binary search is. And as I said that this algorithm is bit complicated as compared to linear search, because linear search was not at all complicated. So binary search, we need to think and we need to progress. The very first thing, before you start talking about binary search, let us talk about the requirement of a binary search. The binary search is different than the linear search. And for a special case, what is special case? The binary search is one, listen carefully, the binary search is one where for sorted arrays only. सो बाइनरी सर्च सिर्फ सॉर्टेड एरे के लिए बनाया गया है. बाइनरी सर्च इज नॉट डिजाइंड फॉर द नॉन सॉर्टेड एरे. यहां पर अपने एग्जांपल देखा था, आई जस्ट टेकन समथिंग इन रैंडम बिकॉज आई नो दैट टेकिंग समथिंग इन रैंडम is more than sufficient. However, when it comes down to the binary search cannot be and should not be used with the unsorted array. I'll give you example. Suppose that you have got a book. And let's say that the book binding is a complete mess. The book binding is complete mess. The pages are put in like any order, and then whichever way is like 1,000 page book, and somewhere you want to find out the page number 700. So I said that 1,000 page book, it is completely messed. The binding, the pages are literally in any order, the scattered order, and you are trying to read the page number 700. How do you go? How do you go? I guess you have no option other than checking the page one by one. The first page, second page, third page, fourth page. कहाँ पर 700 page number दिख रहा है? That is the only way that you can find out. However, the other way around, listen carefully. Other way around, if the book binding is proper, right? It's 1,000 pages book, but like 1 to 1,000 in a sequence, everything is gone well, and you still want to read the page number 700. You want to read page number 700. How do you read that? Do you go for like a first page, second page, third page? Oh no, no, even though you have got an index table, Gaurav, Sneha, even though you have got an index table, please understand that इंडेक्स टेबल जब आपके पास होगा तो आप लोग इंडेक्स टेबल में आपको पेज नंबर पता चल रहा है. मैं पूछ रहा हूँ, यू नो द पेज नंबर, आपको उस पेज के ऊपर जाना है. हाउ डू यू ओपन अ बुक? आई गेस यू टेक रफली अप टू सम पेजेस. आई गेस आप लोग ऐसे करते हो. अगर आपके सामने कोई बुक होगा, पड़ा हुआ होगा विद पेज नंबर, जस्ट ट्राई करो, उसमें से कोई तो पेज नंबर ओपन करने की कोशिश करो. सो यू नेवर स्टार्ट फ्रॉम लाइक अ पेज 1, पेज 2, पेज 3. यू ऑलवेज like again and not necessarily approximately half always, but then on a rough you just take it like कुछ अंदाजा लगाते हैं हम लोग, निकालते हैं. लेट्स से आपने कुछ तो अंदाजा निकाला और you found that it is 600 page number. What do you do? You find a 600 page number. So what do you do? Now, where do you check? Do you check before that or you check after that? आई गेस यू अंडरस्टैंड वेरी वेल. अगर 600 है तो 600 के पहले देखने का वैसे भी कोई मतलब नहीं है. हमें जो भी देखना है उसके बाद में ही देखना है. अगेन वापस से 600 से हम लोग ऐसा नहीं करते, चलो अभी 601, 602, 603. नेवर. अगेन वी टेक लाइक अ बंच ऑफ पेजेस वंस अगेन, एंड लेट्स से you found that the pages that you found is like a 750 pages. Up 600 page say you jump onto 750. Now what do you do? Now what do you do? Again, up वापस से 750, you know that 700 आपको ढूंढना है, तो it has to be before. So again you find roughly, you come like a nearby 698 or something like a page number. You reach to the 698, so you find that अब एक दो pages आगे है, that you open it. I hope you got the idea. This is what we do in like a real life, and something that we do in real life, obviously we want to do the something similar in a programming as well. तो प्रोग्रामिंग में ये जब किया जाता है, इसको कहा जाता है बाइनरी सर्च. नाउ बीइंग अ ह्यूमन, हम लोग एग्जैक्ट हाफ वगैरह नहीं करते, बट कंप्यूटर इज देयर. कंप्यूटर को आप लोग ये नहीं बता सकते कि अंदाजे से कुछ तो पेज उठाओ. नो, कंप्यूटर डजंट वर्क बाय योर हेयरस्टिक. कंप्यूटर यूजुअली गोज बाय सम डेफिनेट फॉर्मूला, and the definite formula over here is that you divide your array exactly into two parts, and then you divide into two parts, you compare whether the element is matching. If it is matching, well and good. But if it is not matching, the element that you are searching is greater, or element that you are searching is smaller. If it is greater, you focus on a right half. If it is smaller, you focus on a lower half, and again you repeat the same process. Yeah, again you repeat the same process means again whatever that part was there, uska वापस से आप लोग you find out again midpoint, and again you compare. This is a logic behind the algorithm. This is the philosophy behind the algorithm. So पहले जब भी यूजुअली मैं ये जो स्टार्टिंग में आपको फिलोसॉफी बताता हूँ, वहां पर यू मे नॉट फाइंड द होल algorithm clear, but at least you get the core idea of the algorithm. So you should never miss that, so that you remember this. Rest of the algorithm logic building can be done over the period, right? So I'm going ahead. तो सर, ये अभी आपने जो लॉजिक कहा, तो इसको थोड़ा सा algorithm में कन्वर्ट करते हैं. मैंने कहा ना कि वी विल ऑलवेज गो इन सिमिलर फैशन. फर्स्ट थिंकिंग, then algorithm, then implementation. Obviously implementation होने के बाद में analysis. Many times I have seen that लोगों को बहुत जल्दी होती है, सर इसका टाइम कॉम्प्लेक्सिटी क्या है? I always keep telling the people, टाइम कॉम्प्लेक्सिटी बाद में सोचना, पहले algorithm लिख लेना. हेलो, टाइम कॉम्प्लेक्सिटी बाद में सोचना, पहले algorithm लिखना. You always remember that, sir, is efficiency of algorithm is important. 100% the efficiency of algorithm is important, but trust me, the accuracy of algorithm is more important than the efficiency. I hope you got my point. Let's say that, sir, my algorithm is not accurate, but I'm worrying about efficiency. Does it make sense? से मेरा बाइनरी सर्च काम ठीक से कर नहीं रहा है, एंड देन आई एम जस्ट आस्किंग से इसकी लॉग एन आनी चाहिए, लॉग एन स्क्वायर आनी चाहिए, क्या आनी चाहिए? आई गेस दैट वुड बी स्टूपिड वन, इजंट इट? सो ऑलवेज वी विल फॉलो द सेम वे कि फर्स्ट थिंकिंग, then algorithm on paper, then implementation. If everything is okay, we understood algorithm is running, and then we talk about analysis of that algorithm, whether it is fast, whether it is slow, whether it is o of n, whether it is o of log n, वगैरह 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 वगैरह, ये उसके बाद में आएगा. So you keep this thing in mind and tune yourself accordingly so that your life is also simple and my life is also simple. Anyway, I'll go ahead. So sir, how do you find out a midpoint? Like for example, right now I have got an array of 9 elements. In 9 element का हम लोग midpoint कैसे निकालते हैं? तो 9 element का midpoint, तो sir you want to say like 4.5 or something like that, or not really? You please understand that not really. ऐसा कुछ करने की जरूरत नहीं है. You follow the very simple logic. You try to get the nearly half. You try to get the nearly half. I repeat, you try to get the nearly half. एक point कम हो गया या एक point ज्यादा हो गया, उससे कोई फर्क नहीं पड़ता. Correct? If you have 100 pages book, you can make it 50-50. If it is let's say 101 page, then एक में 50 और एक में 51 आने वाले हैं, तो उससे कुछ फर्क पड़ेगा क्या? To be frank, not at all. The algorithm remains same. So do not think a lot on like unnecessary stuff. पहले देख लो. Ultimately your algorithm is going to work, and then if at all questions are there, then your questions are also welcome. No problem. चलो हम लोग आगे बढ़ रहे हैं. And I'm saying that this is nothing but हाँ, एल्गोरिथम कहाँ से शुरू करना है? अभी हम लोग एल्गोरिथमिक थॉट प्रोसेस है. लॉजिक मैंने आपको क्या बताया? इसको एक-एक पार्टीशन को 50% डिवाइड करना है, की एलिमेंट चेक करना है, डिसाइड करना है, लेफ्ट में जाना है या राइट में जाना है, और वापस से उस पार्टीशन को वापस से 50% में डिवाइड करना है. दिस इज अ ओवरव्यू. Actual implementation wise, I said that let us consider that we will have two markers. One is like a left index. ये index है, ये number नहीं है. It is not 11. It is 0. I'm talking about. And this is like a right index. This is like a left index, and this index is right index. So first index I'm saying left. The next index I can say like a right, and then you want to find out the midpoint. The midpoint, for the midpoint. So how do I calculate the midpoint? A midpoint is very simple. For me, the midpoint formula is as simple as what is that? Left plus right divided by 2. See, my formula is very simple. Left plus right divided by 2. Parenthesis to be noted. Don't say left plus right by 2. It's like a left plus right in parenthesis divided by 2. In this example, what is left? Oh, left is 0. What is right? Right is 8. 0 plus 8 is 8. Divided by 2 is 4. So I find like a middle. Oh, this is like a middle element. So sir, which element you are trying to find out? Oh, I'm trying to find out. वो तो मैं बताना ही भूल गया. The element under consideration, the element that I'm trying to search, the element that I'm trying to search is, let's say, 6, 77. This is the element that I want to search. Now in this particular case, how do I progress? और एक काम करते हैं, we'll try to search 88. हाँ, let us get started with. So what is the first thing? You find out a middle element. You first check, listen carefully. You first check the key that you want to search. Is it matching the element? Is it matching the element? Is it matching the middle element? There is some question someone is having. If left plus right is 4.5, then let it be. You should not forget that integer divided by integer gives you integer. I hope Utkarsh that is clear. हम लोग जावा में हैं, हम लोग सी सी प्लस प्लस में है. सो जावा सी सी प्लस प्लस रूल्स आर वेरी simple that integer divided by integer gives you integer and the result has to be like 4 only. So अगर left plus right by 2 अगर आपका 4.5 आता है तो 4.5 आपके मिडल में नहीं आने वाला है, मिडल में 4 ही आने वाला है. एंड ऑलवेज अंडरस्टैंड दैट ये हमारे इंडेक्सेस है. इंडेक्स कैन नॉट बी 4.5. नॉट. अगर आप लोग कल किसी ऐसे लैंग्वेज में काम कर रहे हो, सो जिस लैंग्वेज में हम लोग जब डिवीजन लेते हैं तो हमें पॉइंट में आंसर आता है. लाइक पाइथन में जब हम लोग करते हैं, लेट्स से 0+9 डिवाइड बाई 2, 0+9 डिवाइड बाई 2 आंसर कम्स आउट टू बी 4.5. तो सर ऐसे केस में आप क्या करते हो? कुछ नहीं, ऐसे केस में हम लोग टाइपकास्ट करते हैं. सो वी टाइपकास्ट इट टू द इंटीजर एंड वी से दैट नहीं नहीं, आई डू नॉट वांट दैट 0.5 पार्ट, आई वांट ओनली द पार्शियल पार्ट ओनली. I hope that is clear. And let's continue further. I'm saying that if key is equal to mid, I what is the meaning of this? अगर मैं 55 सर्च कर रहा होता तो I'm saying that I found 55. I found for 55. You can simply return the middle index. Oh, that is very simple. But unfortunately, in our example, हमें वो नहीं करना है. ये तो हमें क्या करना है? अब हमें क्या करना है? आई गेस वी शुड. अब मुझको कहां पर सर्च करना चाहिए 88 को? इन्हें लेफ्ट पार्ट में सर्च करना चाहिए, राइट पार्ट में सर्च करना चाहिए? मुझको लेफ्ट पार्ट में सर्च करना चाहिए, राइट पार्ट में सर्च करना चाहिए? राइट पार्ट में. हाउ डू यू डिसाइडेड? हाउ डू यू डिसाइडेड? द की दैट यू आर सर्चिंग is greater than the middle element. Since key is a greater than the middle element, I said that I should focus onto the right partition. So agar if you say that key is less than the middle element, what do you want to do? I'm saying that focus on left partition, a focus on left partition, and else I can say that focus on right partition. A focus is not a English word or Java, or sorry, is not a Java word or data structure word. I'm just saying that in general English, I'm just saying that since it is greater, now I should only bother about right. What I'm trying to tell you, have a look at this. What I'm trying to tell you, in this particular case, ये जो array का जो part है, इसमें मेरे को कोई लेना देना नहीं है. प्लीज अंडरस्टैंड दैट. ये जो एरे का पार्ट है, इससे भी मेरे को कोई लेना देना नहीं है. आई नीड टू वरी अबाउट दिस मच ऑफ पार्ट. Please note, I'm not even worried about the middle element. Why I'm not worried about middle element? Middle element is already compared. A 55 मेरा already compare करके हो चुका है. So I do not even bother about that. What I'm bother about? Oh, I bother about the element after that. Oh, element after that, I'm going ahead. So how do I do that? I simply say that let us consider for the next iteration. For the next iteration, I want to consider only this much as my array. If for the next iteration, I want to consider only this much of my array where the left is equal to 5 and right is equal to 8. But sir, how do I consider this much as an array? Oh, that is pretty simple. All I need to do is that I need to say left is equal to mid plus 1. All I need to say is that left is equal to mid plus 1. I repeat, मैं mid को वापस से कंसिडर नहीं कर रहा हूं क्योंकि mid को ऑलरेडी कंपेयर किया जा चुका है. हम लोगों ने पहले mid की इक्वालिटी ही कंपेयर की थी. Since it is not equal, that is the reason we went ahead. And now since we went ahead, we are just comparing कि ये लेफ्ट पार्टीशन में है या फिर राइट पार्टीशन में है. अगर ये राइट पार्टीशन में है, अगर राइट पार्टीशन में है, then I want to repeat the same process for all elements after the mid. सो उसमें से राइट पार्ट तो अपनी जगह पे सही है, उसमें कोई चेंज नहीं होने वाला. द लेफ्ट पार्ट ऑफ द राइट पार्टीशन, द लेफ्ट ऑफ द राइट पार्टीशन should be mid plus 1. I hope people you are getting this. Then you continue further and again repeat the process. Oh, you repeat the process. I repeated the process. Bolo, what is to be done? Again find out the midpoint. Hey, what is the new midpoint? 5 plus 8 divided by 2. 5 plus 8 divided by 2, 13. 13 divided by 2 comes out to be 6.5. But 6.5 is not to be considered. 0.5 is to be discarded. So you can say only 6. Okay, I got this. I got this. And again, you continue further and again you compare. Is it matching? Oh, I see that. Sorry, it is still not matching. And if it is still not matching, what is to be done? Again, you check whether 88 is greater, whether 88 is smaller. Again, I found that 88 is greater. Again, if 88 is greater, I understand that I need to focus only onto the right partition. And if you want to focus only onto the right partition, again, I need to repeat it once again. Wait, left is equal to mid plus 1, and you repeat the story once again for this. You repeat the story once again for this. Chalo, go ahead. Repeat the story. Now tell me once again, mid is equal to left plus right by 2. 7 plus 8 divided by 2. 7 plus 8 divided by 2 comes out to be 7. 7.5, 0.5 is to be scrapped. And then I can say that, oh, middle is again pointing to this. Now again you compare. Oh, is this matching? Is keys matching? Yes, key is matching. And if it is matching, return that particular middle index. So your index 7 is to be written. So your logic becomes that simple. Obviously हम लोगों ने जो एग्जांपल लिया था उसमें हर एक जगह पे हमें सिर्फ राइट पार्टीशन में जाना पड़ा था। लेकिन अगर हम लोग ऐसा कोई एग्जांपल लेते हैं जहां पर लेट्स से फॉर एग्जांपल वी विल डू इट वंस अगेन एंड दिस टाइम वी विल ट्राई टू सर्च लेट्स से एलिमेंट 22। You try to search the element 22, we will repeat the whole process once again, and you see that what we need to do it over here. Again, I suggest एक बार तो already मैंने करके दिखाया है. Now it's a good time कि आप लोग उसको मेरे साथ कर सकते हो. Keep your paper, your pencil ready. Do it with me. You will be, more comfortable. At the end, code लिखने का काम हो जाएगा. But पहले algorithm को digest करो कि what exactly it is. Do not by heart the code. Behind the probably the mechanism how this block code came from, which diagrams that we have drawn and which process that we have followed is more important than the actual code. The code will keep changing from language to language. Actually, let us just go back. What we have got is like a left, this is right, this is the middle. On the first iteration, I'm trying to search 22 and I'm doing from scratch once again. Chalo, start. A left is equal to 0, the first index. Right is last index. A last index is typically n minus 1. You know that. If the n elements are there, then the last index would be n minus 1. Go ahead, find. What is that? Mid is equal to left plus right by 2. Yes, you found 4. That is not a problem. What is next? Is it matching 22? Sorry, it is not matching 22. Now, where do I focus? Where do I focus? 22 is smaller than 22 is smaller than the 55. Since 22 is smaller than 55, I should focus only on this much of array. Oh, I should focus only on this much of array. Why don't you go step ahead? And I said that I'll just take it over here. Okay, that is good. What is next? What is next? Repeat the process. Hey, how do you do that? You simply run right is equal to middle minus 1. Right is equal to middle minus 1, so that now you have focus on this. Continue further. Now left plus right by 2. So 0 plus 3 divided by 2 is 0 plus 3 divided by 2 comes out to be 1. Oh, you comes out to be 1, and since it comes out to be 1, you check is the element, is it the same element that you're looking for? Is it the same element that you're looking for? Yes, absolutely. It is the same element that I'm looking for. If it is the same element that I'm looking for, I should be simply returning an index. Please note, I repeated this algorithm second time. So you find that I'm just continuing further. So in either case, so we have written a kind of a loop, and in either case, we found the element. Let me just go ahead and repeat this algorithm one more time. सर बस समझ में आ गया? हाँ, मुझको पता है आपको समझ में आ गया, आप इंटेलिजेंट हो, but still I have to repeat it one more time, considering one more case. Considering one more case, and the case that I want to consider is, let's say that I'm trying to find out element. I'm trying to find out element 40. A 40 is the element that I'm trying to search. Again, do the paperwork and let's see what happen. ये अभी तो आप लोगों ने नोट किया है कि आपको ये वाला पार्ट रिपीट करना है again and again, again and again, again and again. That is something that we understood. But let's see how much time that we need to repeat it. Let us get started. अरे मिडल वहां पर कैसे चला गया? मिडल नहीं वहां पर भेजना है. Right is at the end and middle is at the center. The element that I'm searching, please note, it is 40. Element that I'm searching is, let's say, 40. Let us begin. What is the first iteration? First iteration, middle is equal to left plus right by 2. So obviously the middle is going to be 55. Okay. The element that I'm searching is 40. A 40 matlab it has to be, it is smaller. So you consider that it has to be into the left partition. It has to be in left partition. How do you consider left partition? I simply say that right is equal to middle minus 1. Right is equal to middle minus 1. You consider it over here. Okay, you continue further. You find out the middle once again. A 0 plus 3 divided by 2, this comes out to be middle. Oh, this comes out to be middle. Now it is 22. And now again you are comparing. Please note that this was a second iteration. ये जो था, it was a second iteration. You continue further. You realize that it is 22. What is to be done? If it is 22, what is to be done? Now you see that 40 is matching, 40 is not matching. So again, 40 is greater than 22. Since 40 is greater than 22, I need to focus onto the right partition. I need to focus only onto the right partition, and to focus onto the right partition, I can simply say left is equal to mid plus 1. Go ahead, left is equal to mid plus 1. Again, I'm trying to compare. Again, I'm trying to find out the midpoint. You find the midpoint. Just a minute. I'm trying to find out the midpoint. So count midpoint. A 2 plus 3 divided by 2 comes out to be again 2. It comes out to be 2. It is there. Now again I'm comparing. This is my third iteration. Again I'm comparing, and I still find that 33, the element that I'm searching, is still greater than that. If the element that you're searching is still greater than that, what is to be done? What is to be done? Again you continue further, and you simply say that left is equal to mid plus 1. A left is equal to mid plus 1. So you are going on to the right partition once again. So let us continue once again. Abhi left or right, both are pointing. Please pay attention. Left and right, both are pointing to the same. So obviously, as you said, divide by 2 comes out to be 3 only. Okay, that is good. Now 44. Is it matching 40? Is this matching 40? Or not really? Even this is the last element, still it is not matching 40. And what is to be done? What is to be done? So you consider that the element should be into the lower half. You consider that element should be in the lower half. Because 40 is less than this. If the element is lower half, so what do you say? I want to consider left partition. So right is equal to mid minus 1. A right is equal to mid minus 1. Have a look at this. Have a look at this. Have a look at this. And what do you see over there? Now this is something absurd that you see. What is absurd over here? लेफ्ट क्या था? आपका लेफ्ट वाला इंडेक्स था. राइट क्या था? आपका राइट वाला इंडेक्स था. लेफ्ट क्या था? लेफ्ट वाला इंडेक्स था. राइट क्या था? राइट वाला इंडेक्स था. But in this case, you find that the right is smaller than the left. I'm talking about right is smaller than the left, and this is something abnormal. This is something abnormal which indicate that the element is not available. Which indicate that ये condition सिर्फ तभी होता है कि when element is not available, and this is what tells me. See, पेपर वर्क करने से मुझको पता चला कि मेरा कंडीशन यहाँ पर क्या होना चाहिए. मेरा कंडीशन यहाँ पर ये होना चाहिए, where I can say that the right is less than left. When the right is less than left, at that time I can say that there are likely chances nahi. It means that the element is not available. Element is not available. That's it. In such case, I should always say return minus 1. Return minus 1. This is how you write algorithm. Okay, let us just quickly go ahead. Why don't you type the algorithm quickly and run it? Don't forget, this algorithm works only in a sorted array. So you first ensure that your array is sorted before you actually do the further operations. लेकिन फिलहाल तो मैं बाइनरी सर्च को लिखने वाला हूँ. Public static int, and I'm saying that it is binary search. सर एक नया प्रोजेक्ट नहीं बनाओगे? एक एक फंक्शन के लिए एक एक नया नया प्रोजेक्ट बनाना चाहिए. इतने आपके बुरे हल नहीं होंगे. And I have given proper naming conventions, so I'm very sure you will be able to find it out. So I'm saying somewhere it's like a binary search. Oh, it is there. Now it is binary search. I'm just continuing further. What is next? Let us follow the algorithm. What is the algorithm? you need left index, you need right index, and you also need kind of a mid index. You continue further. What is left? Your algorithm begin with left is equal to 0, array ka left, array ka right, which is the last index. Oh, last index, I can simply say that it is length minus 1. A length minus 1, that is the last index. Now you continue further. You are looking for, what is that? Middle element. Continue and count the middle element. How do you count the middle element? Middle element is equal to left plus right divided by 2. All right, left plus right divided by 2. You want to check, is it matching? Is key is equal to error of mid? If it is matching, just go ahead and return the index. It's very easy. However, if key is less than error of mid, it is less than error of mid, I need to focus onto the left partition. And to focus onto the left partition, I should simply say that right is equal to mid minus 1. Else, I want to focus onto the right partition. To focus on right partition, I can simply say mid plus 1, and I want to repeat the process. While left is less than right. While left is less than right, जब तक left right से कम है, तब तक everything is going well. You just repeat the process. However, जब ये condition false हो जाएगा, ये condition कब false? Sorry, not left. Left is less than or equal to. That is correct, Jaideep. It is less than or equal to. When Shubham, when right becomes greater, then you want to come out. Sorry, when right become less than left, then you want to come out. It is a condition to come out. So मुझको repeat कब तक करना है? मुझको repeat तब तक करना है जब left index is less than right index. When the left index is less than right index, तब तक आपको repeat करना है. Moment right becomes less, that is somewhere you want to come out. Okay, understood? In that case, I can say return minus 1. So that's it. That is the only thing that I need to do in algorithm. Nothing more than that. Oh, why don't you run it? But what is the problem to run this? I want the array to be in a sorted order. So I suggest two ways. या तो ये array लेते वक्त ही sorted order में ले लो, option number 1, or option number 2, since we are Java experts, we already know that array.sort method will ensure that your array is sorted. So I'm just simply finding, oh, this is like array sorted, and then after this, I will be repeating this once again. All right. Is this clear? Whatever is done in front of you. ये मैंने एरे जो भी है, अगर आप लोग यूजर से ले रहे हो तो यू नेवर नो दैट यूजर हमेशा सॉर्टेड ऑर्डर में देगा. तो यहाँ पर मैंने पहले एरे सॉर्ट किया. लीनियर सर्च कैन वर्क, एक मिनट, दिस कैन वर्क ऑन सॉर्टेड और नॉन सॉर्टेड एरे. हाउएवर, तो इसमें को तो कोई प्रॉब्लम नहीं है, बट दिस कैन वर्क ओनली on sorted array, and that is the reason I just ensure that I've done a sorting over here. And if it is clear, why don't you go ahead, and run this. You try to search element. Let's say I am trying to search 33. A 33 has to be at index 2. Okay, that I see. Let's say 99, which is probably at the last index. Yes, I see that as well. You say 11. Oh, it is at the index 0. That is also good. A पहला middle element हम लोगों ने कौन सा search किया था? 55. Within first iteration. Yes, this is also working. Lastly, let me try to find out something which is not available and it is saying not found. So ये दो बार क्यों प्रिंट कर रहा है? एक बार लीनियर सर्च से कर रहा है और दूसरी बार ये बाइनरी सर्च से कर रहा है. I hope that is going well. Why don't you people try it? Correct? So algorithm is pretty simple, pretty straightforward. Obviously, we want to discuss something more about the algorithm as well. As far as even time complexity is concerned, we want to talk about that as well. But I guess now it is almost 11 o'clock. I'm leaving you with the algorithm. You spend a little time on algorithm, or you have your tea, whatever, get fresh. And once you're fresh, we will continue once again, and we will talk about the time complexity, and then we'll move on to the recursion kind of topic, right? Where is that? If you have any questions, please keep them ready. I hope you are there. Okay, so I'm sure that you have done this, and algorithm that we are talking about, like I said, binary search. As the earlier, actually I was writing there the condition, I was writing a condition where it should be false, where it should be false. So earlier when I was explaining, I was writing right is when the right becomes less than left. So that is a condition where it become false. So you want to write a condition, आपको पता है यहाँ पर जो लूप होता है while loop, जब तक कंडीशन ट्रू होती है तब तक के लिए आपको रिपीट करना है. So obviously I have just done the modification accordingly. Yeah, no problem. I repeat once again. Earlier, I was talking about at which condition I should stop. So I was talking about when what the block condition is. So when the condition become false, actually I should come out. So I was talking about that condition. Now I have written a corrected condition over there. So कोई बात नहीं है. Now this is done. Binary search. It is working. So I guess we should also talk about what about time complexity, how it is going to execute. And you will find that this time complexity goes much parallel to what converting a number into binary. So it will be on a similar fashion. So what exactly it means? I'm saying that, see, let's say that you take an array of 16. You take an array of 16. I'm just purposefully taking a halfway proper number so that we can compare it. So I'm saying that you take an array of 16. In a first pass or in a first iteration, you realize either you want to go to the left part or you want to go to the right part. So ultimately, on a next, you will be focusing only on an array of 8, and then again you continued further. Again you continued further. On a next pass, again you are doing two parts, either left part or right part, not both. Either left part or right part, either one. So again you are going to like a 4, and then again you continued further. Again you say that, again you divide further like a part of 2, either left or right, whichever it is, but it is only the two elements. And finally you reach to the single element in a partition, where you realize that either the element is present or element is not present. Either element is present or element is not present. So how many iterations actually it takes? So you can simply say that like a first iteration, second iteration, third iteration, and fourth iteration. So over here, the number of iterations or number of times the loop will be repeating is actually dependent on कि आपका division कैसे हो रहा है. Divide by 2, divide by 2, divide by 2, divide by 2. Worst case, a worst case, I'm saying that you are reaching to the last element. This is the worst case. There can be even a best case. What is the best case? Let's say the element that you are searching is a 55 itself. If the element that you are searching is a 55 itself, in a first go itself, you find out a mid, and then you continue with this. I hope you got the point. In that particular case, so it could be within a single iteration, you are finding an element. That is absolutely possible. But I'm saying that even worst case, let it be to the left, let it be to the right, or whatever, the number of iterations that you will take is actually depends on a division, depend on a partitioning logic. Roughly अगर कहना है, roughly अगर हमें कहना है, so you have a look at this. The number of iterations, I'm saying that, let's say for example, t is proportional to the number of iterations, where I is the number of iterations. I is the number of iterations. But do you know that how many iterations that we take in general. The number of iterations that you take, see in general, have a look at this. 2 raised to I is n. टेक अ लुक एट दिस, 2 रेज़ टू आई इन n। मैंने जानबूझ के अप्रोक्सीमेटली इक्वल टू लिखा है क्योंकि ऐसा कोई जरूरी नहीं है कि आपके पास हमेशा एरे 16 का या 32 का या 64 का एरे हो। दैट इज नॉट नेसेसरी। सो समटाइम यू मे हैव विच इज नॉट पावर ऑफ 2। दैट इज द रीजन आई यूज काइंड ऑफ अप्रोक्सीमेट साइन। सो 2 रेज़ टू आई इज ऑलमोस्ट इक्वल टू n। व्हाट यू आर सेइंग ओवर देयर, यहां पर मैं आपको बताने की कोशिश कर रहा हूं, इफ n इज 16, example you see there, if n is 16, if n is 16, then 2 raised to 4, I'm taking nearby 4 iterations to reach or to search between 16 elements. Okay, that is good. So I understand the number of iterations over here. So problem is that I understand the formula. What about actual iterations? The actual iterations, अगर आपको actual iterations count करने हैं, let us take a log on both the sides. Let's take a log on both the sides. So how you can take that? So log of 2 raised to I is equal to log of n. I'm very sure आपने कभी 9th 10th स्टैंडर्ड में लॉगरिथम जरूर पढ़ा होगा, और अगर आपने पढ़ा होगा तो आपको पता होगा whenever it is a power, then it comes in a multiplication. So I into log n, and I into log n, you continue further. So I is equal to log of n divided by log of 2. A log of n divided by log of 2. That is good, but the time required is proportional to number of iterations. So time required in this case is proportional to log of n divided by log of 2. Oh, is it so? Yes, absolutely. You understand that 1 by log 2 is constant. If 1 by log 2 is constant, you just take it out, and I can simply say that the time required is proportional to log n. And when time required is proportional to log n, you also understand that the time complexity is O of log n. And this is something that I was explaining कि जहां जहां पर partitioning का logic involved होता है, you see the logarithm factor picking in. जहां जहां पर partitioning involved होता है, वहां वहां पर logarithm factor is picking in, जो आपको यहां पर दिख रहा है। I believe that is all right. This is what all about time complexity. तो सर हमें सारे mathematical expressions वगैरह कहीं पर लिखने पड़ते हैं, या someone is asking in an interview? To be frank, not at all, not at all. Again, as the around, as I said, nearby 16 years I'm into the CDAC campus. So CDAC campus, what we see is that maximum time companies first ask you to write a code first. Write a code first, explain the paperwork, explain the algorithm very well. So as long as you are a good coder, so there are likely chances that you are placed. And then these time complexities, you should be definitely knowing the end results for solving some sort of a MCQ questions. So which can be the CDAC exam. Many of the companies, they took the technical exam. So technical exam में जो questions आते हैं, बहुत बार time complexity oriented questions आते हैं, और कभी कभी ऐसे भी आते हैं कुछ कुछ स्टैंडर्ड क्वेश्चन, लाइक फॉर एग्जांपल बाइनरी सर्च टाइम कॉम्प्लेक्सिटी इज ओ ऑफ लॉग एन। ये सारी दुनिया को पता है, सो देयर इज नथिंग ग्रेट इनटू दैट। सो दोस कुड बी द क्वेश्चन। Sometimes the question is they give some sort of algorithm, and for this algorithm what will be the time complexity? They just give some algorithm कि ये ऐसे ऐसे algorithm है या ऐसे ऐसे code लिखना है, so you write a code, and after that probably you are discussing, okay, what is the time complexity of this? Now when these kind of questions are there, as I said that in MCQ exams, at that time you should be in a position to understand it. You should be in a position to at least get a idea where out of 4 options that you can mark, and that is the reason I'm showing you the derivations. Otherwise these derivations are not directly important to you. जितने standards हैं, I would always recommend that वो by heart कर लो कि इसका time complexity O of log n है, linear search का time complexity O of n है. That is something that you need to by heart, but you always go through the mechanism once कि how you come from a derivation, so that अगर इसके सिमिलर कोई नॉन स्टैंडर्ड एल्गोरिदम होगा जिसके लिए अगर आपको सोचना पड़ा, तो आपको थोड़ा बहुत कैलकुलेशन पता होना चाहिए। दैट इज द रीजन आई वाज शेयरिंग विद यू कि व्हाट इज द टाइम कॉम्प्लेक्सिटी, व्हाट इज द एनालिसिस, और ये डेरिवेशन करके दिखाने का रीजन ही है, राइट? सो दिस इज ऑल अबाउट बाइनरी सर्च. इज द बाइनरी सर्च एल्गोरिदम इज क्लियर? अंडरस्टूड? It's good. And if again this algorithm is clear, we should go one more step ahead. And I want to see that there are certain algorithms which can be developed, not necessarily always using loops. There are alternative certain algorithms. So what kind of algorithms? If you take a look at this algorithm itself, take a look at this algorithm. What you're doing, you are starting with the array of, let's say, 8 elements or 16 elements. You starting an array of 16 elements, you find out the midpoint, and after you finding a midpoint, then you realize either you want to go to the right partition or you want to go to the left partition. Earlier you started with the array of 16, but then you say that if the element is greater, so you need to focus only onto the right partition. You need not to focus on left partition. So earlier you will started with the array of 16. Now you are focusing only on an array of 8. Okay, that is good. And then again you can continue further. Again for that 8, you are not searching one by one. What you are again doing? Again you are saying that let us find out a midpoint and let us decide whether should I go to the left partition, whether I should go to the right partition. Again you are doing the something similar. Again you continued. What do you want to do? Oh, I want to find out the midpoint once again. And after you find a midpoint, again you decide whether I should focus on an area of first four or I should focus on an area of next four. What we are doing, we started with the area of 16, then we make it half, area of 8, again we are making half, area of 4, again we are making half, area of 2, again we are making half, area of 1. This technique, where you are not trying to solve the whole problem at once, but rather you are dividing your problem into the multiple ones, the smaller problems, and then you try to solve that. And again, to solve that small part, again you divide it further, and again you try to solve that. This technique we refer it as divide and conquer technique. I'm very sure, being an Indian, we are well aware of the technique. Divide and conquer technique is the same technique that British followed for us, and Indians are really good at that. So divide and conquer. What all we are doing is that, what all we are doing is that we are not trying to solve the whole big problem. We are trying to divide the problem into the smaller problem and trying to solve that. Again, divide it into the further smaller problem and trying to solve that, and so on and so forth. So the typical, I'm saying that this binary search algorithm is typically, you say that it's a divide and conquer kind of problem. But most of the time, again I'm not saying always, but then yes, almost all the time, जहां जहां पर divide and conquer type of problems होते हैं, जहां जहां पर divide and conquer type of problem होते हैं, वहां पर recursion makes it rule. So most of the divide and conquer problems we try to solve using recursion. तो दैट इज द रीजन आई टोल्ड यू दैट मैं पहले आपको linear सर्च बताता हूँ, आपको बाइनरी सर्च बताता हूँ, देन विल गो ऑन अ रिकर्शन. वी विल टेक अ ब्रीफ लुक एट द रिकर्शन concepts. आई एम वेरी श्योर आप लोगों ने इससे पहले पढ़े होंगे बिफोर यू कम डाउन टू द CDAC course, so you must be knowing that. I will revise it. If you have any questions, this is like an ideal time that where you should be asking that. We will sort out the issues of recursion, understand recursion, and once recursion is clear, then we will try to rewrite this algorithm once again. We will try to write the binary search algorithm once again, but now in a recursive manner. So is it what we are going to do? Yes, absolutely. And that is the reason recursion is like a maximum time, maximum running time. This one